Our final lesson in Chapter 8 is 8.6, Solving Rational Equations. When asked to solve a rational equation with one fraction on each side, our goal is to eliminate the denominators. The first thing you'll want to do is factor the denominators just like we did in 8.5. We'll also state restrictions in our domain, just like we did in 8.5. If there's just one fraction on each side, the next step is to simply cross-multiply. Cross-multiplying gets rid of the fraction, so at this point there shouldn't be a fraction left. Then we just combine like terms to solve for x, but we have to check for extraneous solutions. So in this chapter we have extraneous solutions again. An extraneous solution is a solution that you get for x, but it's also a domain restriction. So technically it solves the x variable, but wouldn't work in the denominator. All right, let's try a couple of examples with one fraction on each side. For example A, we have x plus 1 over x minus 3 equals 5. So the first thing I'm going to do is put parentheses around anything that has addition or subtraction. And on the right side, I'm going to make 5 a fraction as well. I'm just going to put 5 over 1. Notice in those parentheses there isn't anything else to factor in the denominators, so step 1 is done for us. It's factored completely. Step 2 for the domain, if x minus 3 can't equal 0, that means our restriction on x is that x can't equal positive 3. We'll check that at the very end with our final answer. Step 3, cross-multiply. This is the step that eliminates the fraction itself. If I cross-multiply from the top left to the bottom right, I have 1 times x plus 1. And if I go bottom left to top right, we'll set that equal to 5 times x minus 3. In this step, the fraction always goes away. From here, we just solve for x. 1 times x plus 1 is just x plus 1, so nothing really changes. On the right, if we distribute the 5 in, we would get 5x minus 15. We have x's on each side, so what I would do is just combine like terms. I'll subtract the x on the left over. I'm also going to move 15 to the left side. The x's cancel. 1 plus 15 is 16. On the right, the 15's cancel, and 5x minus 1x is 4x. To get x by itself, we'll simply divide both sides by 4. 16 divided by 4 is 4. So that's our solution for x. Notice that's not in the restriction, so it's not extraneous. It's a valid option. And that's all you have to do to check for extraneous, is just make sure it isn't one of your restrictions. Example B, 1 over 2x minus 5 is equal to x over 11x plus 8. Again, anything with addition or subtraction, put that in parentheses right away in hopes of not trying to cross off maybe just parts of it. So that's your step 1. 2x plus 5, nothing factors out of that evenly. 11x plus 8, same thing. So we can go right to our domain rule. If 2x plus 5 can't equal 0, we have to actually solve for x. I'm going to move 5 over and then divide by 2. So this means x can't equal negative 5 halves. And then 11x plus 8, if that can't equal 0, move the 8 over and then divide by 11. X also can't equal negative 8/11. Oops, can't equal for that one and that one. So we just have to check our answers when we're done. If we cross multiply in step 3, I'm going to take 1 times 11x plus 8. It's always nice when there's a 1 involved because it really doesn't change much. And on the right, we have x times 2x plus 5. From here, 1 times 11x plus 8 is just 11x plus 8. That's awesome. But watch what happens here. Here we go. If we take x times 2x, we get, 2x squared. Plus x times 5 is 5x. All of a sudden, this becomes quadratic. The fraction went away, but now we have a quadratic equation. And anytime we have a quadratic equation, the rule is to set it equal to 0 and then factor. Sorry. All right, it is what it is. I'm going to move 11x over. There we go. And I'm also going to subtract 8. That way we have 0 on that left-hand side. 2x squared minus 6x minus 8. Now to factor, we could do a times c split to get b, but I recognize that all three terms have a common factor, a 2. I'm going to put that out to the front and then see what's left over. If I take 2 out of 2x squared, we've got x squared left over. 2 out of negative 6x, we have negative 3x. And then 2 out of negative 8, that gives us negative 4. And now what's left over in the parentheses will factor nicely for us. Two numbers that multiply to get negative 4, but add to get negative 3 in the middle. We should use x minus 4 and x plus 1. So now, because we're solving, we can actually divide both sides by that 2 and get rid of it for solving purposes. Because 0 divided by 2 on the left side is just 0. And now we have x minus 4 and x plus 1. If we solve x minus 4, we're just going to add 4 to move it over, and x equals 4. That's not one of our restrictions, so it's valid. And then last but not least, if we subtract the 1, x equals negative 1, also not a restriction, so that's a valid solution as well. This is solving when you have just one fraction on each side. Things progress a little bit more challenging when we have more than one fraction on one side. So take a look at that example 2 below. We've got two fractions on the left and one on the right. What we want to do here is factor first in just the denominator and state our restrictions. And now we're going to go back to finding the LCD. This is going to be an important step. And then in step 4, instead of cross-multiplying, what we're going to do is we're going to multiply the LCD to each side. And we'll distribute it into all the fractions. At this point, we will eliminate the denominator and then go right back to solving for x like we did up above. Like up above, we'll also have to check for those extraneous solutions. Let's try this first example. What is the solution for 1 over x minus 5 plus x over x minus 3 equals x squared over x squared minus 8x plus 15? Again, first things first, anything that has addition or subtraction, I'm going to throw a parenthesis around it. I've had students ask me in the past, is this okay? And unfortunately, it is not. So make sure that anything that has addition or subtraction has a parenthesis in order to recognize that it has to be the exact same in that parenthesis to cancel out. Now, in that second term, x squared minus 8x plus 15, that's actually factorable into x minus 5 and x minus 3. Step 2, let's state those restrictions on x. Notice we have an x minus 5. If that can't equal 0, I'm going to try to get that to fit in there. X can't equal positive 5, so that's one thing we'll check at the end. If x minus 3 can't equal 0, then x can't equal positive 3. So we'll check for those with our final solution. That would be step 2. Step 3, find the LCD. So remember, the LCD is something that all the denominators can go into. And if I take a look at the denominators that we currently have, there we go, we have an x minus 5 and x minus 3, and then a product of x minus 5 and x plus 3. So you guessed it, the LCD is x minus 5 times x minus 3. Now, instead of making the denominators all the same, what we're going to do is multiply the LCD to each side. So I'm going to put my x minus 5 and x minus 3 over 1. And then look at this. I'm going to rewrite that entire original equation. 1 over x minus 5 plus x over x minus 3, and include the equal sign in this bracket. X squared over x minus 5 times x minus 3. We want to distribute the LCD to every fraction. Watch what happens when we do that. If I multiply it to that first fraction, the x minus 5s would cancel out, and we'd have x minus 3 times 1 left over, or just x minus 3. If we distribute it to the second fraction, we're going to put a plus in between them. Now the x minus 3 on top would cancel with the x minus 3 on the bottom, and we'd have x times x minus 5 left over. And the cool thing about this is check out the right-hand side. If I distribute it over to the right-hand side, the x minus 5 and the x minus 3 would cancel with the x minus 5 and x minus 3 that's already on the bottom, leaving us with x squared left over. And in this step, again, the fraction goes away. So now we just need to solve what's left over. The x minus 3, I'm going to go ahead and drop the parenthesis on this because we need to start combining some like terms. If I distribute the x in, we kind of run into this situation where we have x squared minus 5x. On the right, we have another x squared. So again, this is going to be quadratic, but not as crazy as you might think. If we move that x squared over to set it equal to 0, guess what happens to the x squareds? They cancel out. And then if we combine like terms, this x minus this x is just negative 4x minus 3 equals 0. And now that's basic algebra. Let's figure out how to get x by itself. We'll add 3 to move it over. And then we'll divide by negative 4. We get a solution for x. X equals negative 3/4. Double checking our restrictions. I think it's valid. That's our final solution. Here's another helpful example. 5x over x minus 2 equals 7 plus 10 over x minus 2. I'm going to put the x minus 2's in parentheses and make 7 a fraction. So I'll put that over 1. Notice none of my denominators need to factor, which is kind of nice here. We'll state our restriction for the domain. If x minus 2 can't equal 0, that means x can't equal positive 2. And we'll check that with our final solution. The other nice thing about a problem like this one is both of those denominators are the same. To get our least common denominator then, it's just x minus 2. So this should run pretty smoothly for us. If we put x minus 2 over 1 and distribute that into the entire equation, we'd have 5x over x minus 2 equals 7 over 1 plus 10 over x minus 2. If we distribute that into the first term on the left-hand side, the x minus 2's would just eliminate right away, and we'd have 5x. If we distribute it into that first fraction on the right-hand side, nothing cancels out. That means we have to multiply 7 times x minus 2. And then if we distribute it to that second term, the x minus 2 on top would eliminate with the x minus 2 on the bottom, leaving us with just 10. And there isn't even a quadratic to worry about here. What you want to do is eliminate the parentheses, so let's distribute the 7 in. We have 5x equals 7x minus 14 plus 10. And that would be 5x equals 7x minus 4. If I move that 7x to the other side, we get negative 2x equals negative 4. To get x by itself, when we divide by negative 2, we get x equals 2 as an option. Check this out. That was a restriction. Because of that, x equals 2 is extraneous. Our solution doesn't actually match for the restriction within our domain. Our final example in Chapter 8. 2x plus 2 over x minus 1 equals 4 plus 6x over x plus 4. Again, anything that's being added or subtracted, I'm going to put in parentheses, and we'll write that 4 over 1. Notice when we factor, I'm not worried about that 2x plus 2, even though it is technically factorable. I'm just focusing on the denominators for step 1. We have x minus 1 and x plus 4. Neither of those have to factor further, so we'll go straight to our domain. If x minus 1 can't equal 0, then x can't equal 1. If x plus 4 can't equal 0, then x can't equal negative 4. Easy enough. To get our LCD, we have an x minus 4, a 1, and an x plus 4. Our least common denominator then is just the product of those two parentheses in the first fraction and the very last one. That means I'm going to write x minus 1 and x plus 4 all over 1, and then the process of rewriting that whole fraction. So I know this gets a little tricky. 2x plus 2 over x minus 1, there we go, equals 4 over 1 plus 6x over x plus 4. Now, this one gets a little messy, so take your time and make sure you're following along. When we distribute this first term, or the LCD into the first fraction, the x minus 1s would technically cancel. But we'd still have x plus 4 times 2x plus 2. And we'll have to FOIL that. And then it gets even crazier. If we distribute it to the right-hand side, nothing cancels, meaning we have 4 times x minus 1 times x plus 4. If we distribute it to the last fraction, the x plus 4s would cancel, but we'd still have 6x times x minus 1. What I want you to do right now is pause the video and then FOIL this. Pause, or keep paused, FOIL this, and then distribute the 4 in, and then distribute that in. Then press play, and we'll start combining like terms. But make sure you actually pause the video and FOIL it first, otherwise there's going to be a lot of information in the next few seconds. Are you ready for this? I FOILed the first terms on the two parentheses on that left-hand side and ended up with 2x squared plus 10x plus 8. I FOILed the x minus 1 and the x plus 4 and distributed the 4 in to get 4x squared plus 12x minus 16, plus then I distributed the 6x in and got 6x squared minus 6x. For now, I'm going to leave the left-hand side as is, but then combine like terms on the right-hand side. 4x squared and 6x squared would be 10x squared, and then 12x minus 6x is plus 6x with a constant of negative 16. And yep, you guessed it, this is quadratic. That means we have to set everything to one side, or set it equal to 0 by moving everything to one side. I'm going to keep everything on the right-hand side since the 10 is bigger. I'm going to move that 2x squared over, and I'll move the 10x over, and I'll move the 8 over. And that gives us 0 on that left-hand side. 10x squared minus 2x squared would be 8x squared. 6x minus 10x is negative 4x. And negative 16 minus 8 would be negative 24. Now you'll notice when we solve, we're going to have to do a times c eventually, but first we can factor out a 4. And that will just make the parts left over, hopefully, easier to work with. Gives us 2x squared minus x minus 6. We could even divide that 4 out right away since we're solving, not just factoring. And that would give us 2x squared minus x minus 6 to solve. Yep, we are going to have to do a times c on this one. So let's go ahead and do that. A times c. 2 times negative 6 is negative 12. Numbers that go into 12 are 1 and 12, 2 and 6, or 3 and 4. We want negative 1 in the middle. That means we'd have to make the 4 negative and the 3 positive. I'm going to split that up and do minus 4x plus 3x, and then put that 2x squared out in front and the minus 6 at the end. We'll group the first two terms and the second two terms. In 2x squared minus 4x, we could take out a 2 and an x, and we'd have x minus 2 left over. 3x minus 6, we could take out a 3, and we'd have x minus 2 left over again. That means x minus 2 is one parenthesis, and 2x plus 3 is the other. Again, this equals 0, so now we just have to split them up and solve them separately. If we set x minus 2 equal to 0, x would equal positive 2. That's not one of our restrictions, so that's a valid solution. If we set the 2x plus 3 equal to 0, remember you have to solve for this, move that 3 over and then divide by 2, we get x equals negative 3/2. Also not in our restriction, so there's another answer for us. And that's it for lesson 8.6.